Okay, so the exponential function is a function of, with the base a, is a function of the form f of x equal a to the x. So again, a here is like number, real number, greater than 0, and also a not equal 1. And this x is a real numbers, belong to the real numbers. So it could be like negatives, positives, fraction, 0, anything. But a here is not equal 1, because if a equal 1, the function become like f of x equal 1 to the x, like this, f of x equal 1 to the x, and this is equal 1 because 1 to any number is 1. And this function is not exponential function, is a constant function. So that's mean a here is not equal 1 because the function become constant function, not exponential function. Okay, so a not equal 1. Also, we have like there is example for exponential function. For example, like f of x. Give you example for exponential function, like f of x equal 3 to the x. This is exponential function. For example, f of x equal 1/3 to the x. This is also exponential function. F of x equal -2 to the x. Also, this is an exponential function. All of these are example for exponential function. Also, we have to know how to graph the exponential function. So there's another example here, evaluation, how to evaluate the exponential function. Evaluate. So let my function, my exponential function, let f of x equal, for example, 3 to the x. And the question is, find f of 2, b, find f of 3, c, find f of 5. So for the first one, f of x equal 3 to the x. Here f of 2, we plug the 2 inside this function. So for a, f of 2, we plug the 2 inside this function, so they give me 3 to the 2, 3 to the power 2. And 3 to the power 2 is actually 9. For the second one, who will do the second one? B. What is f of 3? Just you have to plug this one
To
inside
the third power.
to the third power. So 3 to the 3. And what is the answer?
27.
27, yes. For the third one, C, f of 5, same things. You plug the 5 inside this function, give me 3 to the power 5. And again, 3 to the power 5 is like 3 times 3, 9, 9 times 9 is 81. 81 times 3 is 200. 43. Okay, so it's direct to evaluate, just you plug the number inside the function and you get the answer. Now we're going to the any question before we go to the graphing? Is it clear how to evaluate? So here's the definition, and down is example. Okay, now we're going to the how to graphs exponential function. So graphs of exponential functions. So like before, to graph the exponential function, we're going to start by using the plotting points. So the example, start by example, graph each of the functions. For A is f of x equal 3 to the x, and for B is g of x equal 1 over 3 to the x. Here's x. So we're going to make a table. For this function and this function, we're going to make a table. So here is table. This is the value for x here. This is the value for f of x, and here is g of x. So here is x. Here is f of x. I'm going to graph the both of the function at the same time. This is equal 3 to the x, and here is g of x equal 1 over 3 to the x. I'm going to use like easy numbers sample, like 0 and -1, -2, -3. Here on this side, I'm going to use positive numbers like 1, 2, 3. Okay, who will do the first one, the first point for the 0? What is f of 0? After you plug the 0 inside the function f. What is f of 0?
1.
If I start from 1, 0 here, f of 0 is 3 to the 0 is 1, exactly. So f of 0 here, f of 0 equal 3 to the 0, and this is equal 1. What is f of 1? F of 1 is equal 3 to the 1 is, what is
3.
it? 3. And what is f of 2?
9.
It's 9. And the last one of 3 is
27.
27. Same things for the negative numbers. For the -1, what is f of -1?
-3.
No, you have to plug the -1 inside the function. It's not
Oh.
-3. So they get what? 3 to the -1, right? And what is that equal? What is a 3 to the -1?
1/3.
1/3, exactly. The reciprocal. So this is equal 1/3. That's true, Juan. What about f of -2? You plug the -2 inside this function, they give me 3 to the -2. And what is 3 to the -2? Is 1/9.
1/9.
Yeah.
Yeah.
Yes. Because this is like actually is 1/3 square, because the minus I said before, it's the reciprocal. It goes down to the denominator. So 1/3 square, and 3 square is 9. So this is 1/9. What about -3? F of -3 is 3 to the -3, and this is equal
1/27.
1/27. So this is 1/27. Now I'm going to do the same things for g of x. Starting from the 0. What is g of 0? G of 0 is 1/3 to the power 0. What is it?
It's 1.
Is 1. Same things for the minus. So when I plug the g of -1, they give me 1/3 to the -1, and 1/3 to the -1. This means we have to do the reciprocal for inside the parentheses. So this is equal 3. G of -1 is 3. What about g of 2? -2. Plug the -2 inside the function, they give me 1/3, everything to the -2. And what does that give me? The minus means we have to flip. And the 2 we have to square after we flip. So this is equal 3/1 square, and this is equal 9. Exactly. So g of -2 is 9. The same things for -3 is 27. G of -3 is 27. So look, 1, 3, 9, 27 in the green line, 1, 3, 9, 27 in the brown color, this color. The same things for the 1, 2, 3 here. So g of 1 is the same as f of -1 is 1/3. And again, g of 2 is equal 1/9. And last one is g of -3. I mean, g of 3 is the same as f of -3 is 1/27. Now this is graphing. So I'm going to go to the graphing here, this area. Okay. This is my x-axis. This is my y-axis. This is my x-axis. Okay. Okay. I need 0 and -1, 2, 3. So here is 0, 1, 2, 3. And in the same times, the minus is -1, -2, -3. For the element here, for the y values is 1, 3, 9. So this is 1. The 1 be like here, like 3, 9, 27, 3, 9, 12, 15, 3, 6, 9, 12, 15, 18, 21. So now let's graphing the f of x, the green one. So at 0 is 1. At 0 is 1. The 1 is like around here. This is the value is 1. At 1 is 3. Here is 1. Value is 3. At 2 is 9. Here is 2. 9 like around here. At 3 is 27. 3 is 27 like up. So the graph will be like something like this. Here is like close to the x-axis. The same things from the minus is -1 is 1 over 3, like around small numbers less than 1. -2 is 1 over 9, like close to the, all the elements here like become like so close to the x-axis. Okay, so the graph would be like something like this, close to the x-axis, and here would be like more like something like this. Okay, so this is the graph for the green one, the f of x. Here, f of x. Three to the x. So this is f of x equal 3 to the x. Any question for the first function? Yes, what is the domain for this one? What is the domain for this function, as we talked about this last time? What the x value are used for this function? Yes, it's from negative infinity to infinity. This is the domain. This is true. So the domain is what's the value, what's the x value are using. Here, as we see, all the x negative values are used, all the negative numbers are used, and also all the positive numbers are used. So the domain will be like the real numbers, all real numbers. Now for the second function, at 0 is they give me 1, the same point. At 1 is 1 over 3, so 1 over 3, like this is 1 over 3. At 2 is 1 over 9, like around here. At 3 is 1 over 7, 27, like become so closer. When the number become more larger, all the numbers here become so closer to the x-axis. And the same things from the negative numbers. At -1 is 3, so this is -1 here, is 3, like around here. And -2, they give me 9. This is 9 here. So the graph will be something like this. Here goes to, it's not nice. Here's become like this. This side. Close to the x-axis. And from this side here, be like more bigger, large, like this. Okay, so this point here, come here. Oh, we don't need it. So the point at minus 3 is like around 27. So like a more large number, like 27. Minus 2 from the table is 9. So be like around here. And minus 1 is 3. So again, what is the domain for the g of x, the function g of x? What is the domain for g of x?
Negative infinity to infinity.
Yes, the same things. All the x values are used for the other function. So also the domain for the second function is from negative infinity to infinity. Look to this function, the green one and the brown one. It's like there is a some property between of them. Like as we see here, if we reflect the green one around the y-axis, if we reflect this one around the y-axis, this axis, I mean, this axis, we'll see the brown one. This means the reflection for the green one around the y-axis, they give me the brown one. So f of x and g of x, like the function f of x is reflected, I mean g of x is reflected around, is like a graphing for the function f of x, and then we reflect it around the y-axis. So I can say here, the function g of x is equal 1 over 3 the x, and this actually is equal 3 to the minus 1 everything to the x, because as we said before, if I want to raise this 3 to the up to the numerator, I have to change the exponent, so the exponent become negative. Now this is equal 3, now we multiply the exponent, equal 3 to the minus x, and my function f of x is given as 3 to the x. So there is a relation between g of x and f of x is to graph this function, this is equal actually f of minus x. If we plug the minus inside the function f of x, here f of minus x, they give me 3 to the minus x. And this is actually equal to the g of x, the function g of x. So this is mean to graph the function g of x, we need to graph the function f of x, then we reflect it around the y-axis because the minus is inside the parentheses for the function f of x. Makes sense? Is it clear what I said? Any question? So this means to graph the function like this, 1 over 3 to the x is the same as, write it as this, 3 to the minus x. Then we graph the original function. The original function is f of x equal 3 to the x. Then we reflected this one around the y-axis because the minus is in the exponent.
Professor, I'm sorry, I came late. Can you go back to the previous slide with the chart? Just give me a quick rundown on how that works.
Yeah,
I just
sure.
came in.
Okay, no problem. Yes. Okay, sure. Here the domain for the function f of x and g of x is all real numbers, or I can say it from negative infinity to infinity. Here open parentheses. the range will be like not the same. No, the range is what the y value are used. So if we look into the graph, we see here the y value starting from the 0, but the 0 is not included. Why? Because this graph will be like close to the 0, but the 0 is not included, and all the positive numbers are used. So from 0, open parentheses, to infinity, positive. Okay, Christopher? Christopher asked, what's the range? So the range is open parentheses from 0 to infinity, and the 0 is not including the range. Why? Because here in the graph, this here will be close to the y-x-axis, but the x-axis is like the 0 for the y is not including inside the range. Now here we can set the x-axis is the horizontal asymptote. So my asymptote here is horizontal, is the x-axis. Now can I move to the next slide?
Yes, thank you.
Okay. So let me write down. So the domain for f of x and the other function g of x is from open parentheses minus infinity to infinity. And also I can set the range for f of x and g of x is the open parentheses from 0 to infinity. So after that, after we see here, so I can set the graphs for all exponential function look like this. I'm going to move to the next slide. So it's gonna be something like this. Okay, so it will be something like that. Here for f of x equal a to the x. Again, a is any number greater than, for all a is greater than 1, like 2, 3, 4, 5, 6, and it's going to be something like this. Like this. For f of x equal a to the x, but here a is between 0 and 1. Here, like f of x, example for that, f of x equal 5 to the x, or f of x equal 10 to the x. Here, example, f of x equal 1/2 to the x, or f of x equal 1 to the 3, everything to the x. So this is f of x here, equal a to the x, and here f of x equal a to the x. here x-axis, and this is my y-axis. Here's the y, and here's the x. Okay, last time I gave example how to find the exponential function. So example for this, the question is find the function f of x equal a to the x. But this time they give me graphs. A graph like this. And I'm going to do the second one because I left it, and this function is like something like this here. And this function is basing the point 3, 1 over 8. So because the function look like this, so it's gonna be like a fraction. A, it will be number between 0 and 1. This a will be a number between 0 and 1 because the function look like this. So first of all, 3 and the point, they give me the point 3, 1 over 8. This means f of 3 is 1 over 8. Okay. So if f of 3 is give me 1 over 8. And they told me f of x, the function f of x equal a to the x. Find the value for a. This is my goal, to find the value for a. So first of all, I plug the 3 inside this function. So they give me f of 3 equal a to the 3. And already they give me the answer for f of 3. F of 3 equal 1 over 8. So this is equal 1 over 8. Again, I plug the 3 inside this function. They give me a to the 3. And they give me the answer already. F of 3 is 1 over 8. Now I have to change for these things and make it like equal fraction to the power 3. What element, what number can I put inside the parentheses such that the exponential for this number to the power 3, they give me 1 over 8. So the best number is 1 over 2. Because 1 over 2 to the power 3 is 1 over 8. So this means a here equal 1 over 2. So now my function is f of x equal a is 1 over 2 to the power x. Any question? Any question? Is it clear?
Yes, it's clear.
Okay. So now after I know like the knowledge, how is the graph for the exponential function, it's gonna be something like this or something like this. So now I'm going to graph by using the transformation by 2.6, section 2.6. So let me give you example. So by using the transformation, I have to do the graph. So transformation. Okay, so using the graph, the question is the example. Using the graph f of x equal 2 to the x. Sketch or graph each of the following. So the first one, A, is g of x equal 1 plus 2 to the x. B, h of x equal minus 2 to the x. And C, d of x equal 2 to the minus x. Okay, who would do the first one, or give me like the idea how to graph this one by using the transformation? Tell me what's the, so my original function is given in an example. They told me f of x equal 2 to the x. Then by using this function, graph this. How can I graph the first one? What does that mean, 1 plus 2 to the x? What is the mean of 1 plus 2 to the x? How can I do the transformation here? Okay, let me simplify it. So the function f of x equal 2 to the x has a graph because 2 is greater than 1. So 2 is greater than 1, the graph will be look like this, number 1. The graph like number 1. And here number 2. The graph has a shape like this. Why? Because I said f of x equal a to the x. A is greater than 1. The graph will look like this. So my original function has a graph like this. This is 2 to the x. This is f of x equal 2 to the x. Now, how can I graph the function g of x? What does that mean, 1 plus 2 to the x? What does the mean of when I add number to the original function?
You have to move the graph depending on the number. Like that's the
Yes,
shift.
exactly. Exactly. Here we're doing shift, but how is the shift will be look like? Like up, down, left, right.
Isn't it to the right, one space and an up two in that case?
Okay. Okay, let me explain more. Like if I need it to the right, the number will be inside the inside the parentheses. Like I mean, if I need it to the right, it's supposed to be 2 to the x minus 1. Like if the number inside the exponent, it will be right and left. But if the number is outside the exponent, like this, so this is mean we have to shift it upward 1 unit. Like Chris, he said, like we shift all the graph upward 1 unit because the number is outside the parentheses. Actually, the parentheses is in the exponent, inside the exponent, like in the red here. Because the number is not inside the parentheses outside, we have to shift it up and down. So the one, when shifted up, the one here become 2. This is number 2. And the x-axis here, we shifted up 1 unit. So the asymptote, the x-axis, I mean, will be like shifted up 1 unit like this. Now, all the graph will be close to this line, but will not touch this line. They will not touch this line because this is my asymptote. So this is my asymptote. It will be like this. Is not like this. Is not an origin line, but gonna be shifting all the function 1 unit to the up, like this. So my new function will be graph like in this side will be close to the 1 to this line like this, and then we go up like that. So the graph will be something like this. This is my function g of x equal 1 plus 2 to the x. For the second one, again, my original function, if you want to think that, is equal 2 to the x. Then we adding 1 from outside. If we want to do the steps like before, add 1 to the outside. Let me do it step by step to explain how we shifted 1 unit. So my original function O of x or f of x, I'm going to call it O of x as O is original, equal 2 to the x. So I add 1 from outside for this function. Now I get O to the x plus 1 equal 2 to the x plus 1. And this is my g of x. So to graph the function g of x, I have to graph the original function O of x, and I have to shift it 1 unit up because the 1 is outside the function. This is for the first one. Who will do the second one? This is for first one. Second one, h of x. What is the mean of the minus 2 to the x? What is the mean of h of x equal minus 2 to the x? So again, my function is f of x. I'm going to use this function. This is my original function, 2 to the x. And I need to graph the function h of x equal minus outside 2 to the x. Where we have the minus, this mean like we have to do reflection, but where is the reflection exactly we have to do it?
The x-axis.
To the x-axis, exactly. So if I want to think for this one, like the steps before from the previous section, I said my original function O of x is 2 to the x. This means we have to multiply both sides from minus from outside. So multiplying this by minus 1 from both sides, I get minus O to the x equal minus 2 to the x. And here minus 2 to the x will give me h of x, this function. This is equal h of x. So to graph this function, I have to graph this function. Means I have to graph the original function, then I have to multiply by negative outside the function. This means we have to reflect it around the x-axis because the minus is outside the function. So the function 2 to the x, I know to graph for this one, like before, is something like this. Like this. This is the function 2 to the x. This is f of x equal 2 to the x. Now to graph the h of x, I have to reflect the original function, this one, around the x-axis. So here is my mirror, the x-axis. Reflect all the point around the x-axis So at this point here is 1. Now become -1. So here become -1. And all these points become like this. And this point become like this. Like this, close to the x-axis. So this is my h of x equal minus outside 2 to the x. Any question? Is it clear? Do you have any question? Okay, for the third one, to graph the function d of x equal 2 to the minus x. Look to the minus, where is it? It's inside the exponent. So it's inside the function, I mean, inside the exponent, this means inside the function. So to graph this function, so again, my original function is f of x equal 2 to the x, and number C, they ask me to graph d of x equal 2 to the minus x. What does that mean? How can I graph this one? How can I graph this one? What is the minus inside the function? How can I graph it?
You reflect it along the y-axis.
Y-axis, exactly. Because the minus is inside the function, like I said, graph the function f of x, f of minus x, like this. When the minus is inside the function, this means we have to reflect it around the y-axis. Again, if I want to do it step by step, so my O of x, the original function, is 2 to the x. Now I need to modify this function such that they give me d of x. I have to plug the minus inside. So they give me my O of minus x equal 2 to the minus x. And this is equal d of x. So to graph the function d of x, I have to graph the original function. Then I have to reflect it around the y-axis because the minus is inside the function, inside the parentheses. Here we plug minus x. So we reflect all the point around the y-axis. So my mirror now, it's the y-axis. It is it. Now all the point we reflected around this one. So this here, the one will be the same things, and everything become like this. And this one becomes something like this. And this is my d of x equal 2 to the minus x. Any question? Is it clear? Is it clear how to graph the function? If you have any question, you can ask your question.
Is it possible? Can you go over back that, please? I was a little bit confused.
Which one?
Like how
This
to
one?
graph it? No, the one before, after, the one after that one.
This one?
No, the one we were just
Or
did.
this one?
Yeah.
C?
Mm-hmm.
C.
Yes.
The graph? Okay. So the original function O of x is equal 2 to the x. I mean, for original function is f of x. Now, if we plug the minus inside the function, I get O to the minus x equal 2 to the minus x. And this actually is d of x. So this is equal d of x. Now, to graph the function d of x, this one, to graph this one, I have to graph O of x. Then because there is minus inside, I have to reflect it around the y-axis by using the rules in section 2.6, the previous section. So I have to graph the original function is f of x, or the black one. This is the graph of 2 of x, 2 to the x, I mean. Then I have to reflect it around the y-axis. This is my y-axis. The point here will be reflected in the same point. This is like my mirror. All the points become like the same as in the red curve. And the same things in this side. Reflecting for this one become here. Again, if you have like the minus inside the exponent, this means we have to reflect it around the y-axis. If the minus outside the exponent, we have to reflect it around the x-axis. If we add number to the original function outside the exponent, then we have to shift it up and down. If the number is inside the exponent, then we have to shift it left and right. So I'm going to give you exercise. So my exercise is, hold on one second. Okay, so I give like, let me check. I give this. Now my exercise will be something inside the exponent. So here my function is graph the function, graph the function like s of x equal 2 to the minus, no, I make it like more simple, x minus 1. So look, the minus is inside the exponent. Okay, this is exercise for you. So by these things, we finish this section. Now we have to go to section 4.1.3. Any question? Okay, so now let's go to the 4.3 is the logarithm function. So the logarithm function here, 4.3, functions. So the logarithmic function is the inverse of the exponential function. So I can say here is the inverse function of exponential function. So this is the inverse for the exponential function. This is the inverse for 4.1 for the previous section. Let me define it. So definition, the function, the logarithmic function with base, the base is a, be something like this: log to the base a of x, for example. So I have to know log x to the base a, if it's equal y, this is equivalent to a to the y, a to this y, a to the y equal x. So log x to the base a equal y, this equal a to the y equal x. So again, this is the base, is a. This is in the logarithm form. You can set here. This is in the logarithm form. This is in the exponential form. This is logarithmic form. This is exponential form. So there is a relation between the logarithmic form and the exponential form. Both of them are inverse to each other. So let me give you example. So the example is find, evaluate. First one, log 1000 to the base 10. B log 32 to the base 2. What is the answer for the first one?
Ten.
What's the answer? What you said, n?
Is it 10?
10. Okay. How you think for this one?
10 to the 10's exponent is 1000.
Yes, but 10 to the 10 is not 1000.
I
10 to
mean,
the power 10 is not 1000. 10 to the 10 is, you give me like 10 times 10 times 10 times 10
It's
times
third.
10 times 3 is the good answer. This is the right answer, so it's 3. But Mobin, she said 10 to the 10, like 10 to the 3, they give me 1000. The same like idea. So 10 to the 3 is 10 times 10 times 10, they give me 1000. So the answer is a 3. Why? You said what exponent, if I raise it to the 10, they give me 1000. Like this, you think. You said which number 10 to the which number x, they give me 1000. my goal right now to find what's the value for x. So the value for x is 3, and this is the answer for the logarithm. Okay, so to think for this again, I said 10 to which power or exponent they give me 1000. So x, now then I said x equal 3, and this is the answer. X here equal 3. So this is the answer for the logarithm. For the second one, two to the which power they give me 32.
5 is 5.
5, exactly. So here the answer is 5. Why? Because again, the same idea. 2 to which power they give me 32. So this is mean x equal 5. Here x equal 3. Using this property, exactly the same like this property. Here, logarithm x to the base a equal y. I need to find y. I said a to which power a to which power y equal x. Give me the answer. Here, this x. Okay. Now, some property of logarithm. Properties of logarithm. Here. There are some properties of logarithm. First one, I have to know the logarithm for the one for any base. I will put it in red color. Is always 0. Why? Because a to the 0 is 1. Because this a to the 0 is always 1. So the logarithm to the 1 is always 0. Second one, log a to the base a is equal 1. Why? Because a to the 1 is always 1, always a. Because a, this a to the 1, they give me a. I write it in red color. This a. And the red color to the 1 equal a. Third property said log a to the power x to the base a is equal x. Same idea, a to the x equal a to the x, and this is true. This a, I mean. A to this x equal this x. A to this x equal a to the x. So a to the x equal a to the x. This is right. Number 4, a to log x to the base a is equal x. Okay. Any question for these properties? Is it clear? So let me give you example for this. So example here. First one, find the log 5 to the power 6 to the base 5. Number 2, log 1 to the base 10. Number 3, log 6 to the base 6. What is the answer for the first one? Log 5 to the power 6 with base 5.
Isn't it 6?
The first one is 6, exactly. Why? Because by using the property number 3. By using property number 3, here I have the base the same, like a and a are equal, 5 and 5 are equal. The exponent is 6, so the answer is 6. For number 2, log 1.
So it's 0. Oh, sorry.
Is 0. Yes. So log 1 for any base is always 0. For number 3, is 1. Yes. Because log 6 to the base 6 is 1. Log 7 to the base 7 is 1. Log 1000 to 1000 is 1. So the answer here is 1. Any question? Any question for this? Okay, now if there is no question, we're going to the graphs of logarithm function. So first of all, I said the logarithm function is the inverse function of the exponential function. So this is gonna help me for graphing the function. So here, graphs of logarithm function. So I know the exponential function. It has a graph something like this, like I said in the previous section. If I want to graph the function f of x equal a to the x and a is greater than 1, the graph will be something like this. Like this. Okay? So this is the graph of the function f of x equal a to the x. Now, to graph the function, logarithm function, this means it is the inverse of the function. What does that mean? How can I graph the logarithm function by using this function? Like before, we talk about the inverse function. How we can graph the inverse for this function? Do you remember when I said to graph the inverse function, I have to reflect it around the line y equal x? So I have to graph the line y equal x Then I have to reflect all the points around this line. So this is my y equal x. This here, the line y equal x. Now I have to reflect all the points in this graph, in the red one, around this line. So the reflection for this point is 1. The reflection for this point will be like around here. This is 0 and 1. This is 1 and 0. And the reflection for all this line here be something like this. And for these things here will be something like that. So it's gonna be like close to the y-axis, but they will not touch the y-axis. So this is the logarithm function. Log x to the base a. And this is my function f of x equal a to the x. Here I can call this function as s of x. So the logarithm function will be graphed like this by the green one. Any question? Now, what's the domain for the logarithm function? What is the domain? What's the x value are using? What's the x value are used? As we see here, all the x-axis, the positive x-axis are used. Like if we're looking from here, I see all the points, but except the 0. The 0 is not including in the domain because here the curve will be like close to the x-axis, but we're not going to use the 0. So the 0 is not used, and all the positive real numbers are used. All these numbers are used. So I can say the domain will be the open interval from 0 to infinity. And I have a vertical asymptote is the y-axis. And what is the range? What is the range for the logarithm? So as I see in the picture, the range is all the y values are used. So this is mean it's the real numbers. I mean like from minus infinity to infinity. I have a vertical asymptote is x equals 0. So I have a vertical asymptote is x equals 0. So here I can set I have a vertical asymptote is x equals 0. This is me in the y-axis. X equals 0 is the y-axis. Any question? Is it clear? So I have vertical asymptote for the logarithm function is x equals 0. Okay, now we're going to learn how to graph by using the transformation. So now my logarithm function will be something like this, the green one. Always look like this. This is my original function graph, the green one. So now I can set a graphing by using the transformation. So example, by using the transformation, graph each of the following. My function is f of x equal logarithm to the base 2 of x. I need to graph each of the following. Number 1, g of x equal minus log x to the base 2. Number 2, h of x equal log of minus x to the base 2. Number 3, d of x equal log 2 to the x plus 2. Or I make it 2 plus logarithm of x equal 2 plus log of x to the base 2. Who will do the first one? Or give me the idea for the first one. What is the mean of minus here? So for the first one, I know how to graph the original function is logarithm function of x. It has a graph like this. Here 1, like this. This is f of x. Who will do the first one? This is f of x. What is the mean of minus outside the function? Reflecting, exactly, but the minus outside, what does that mean? Reflecting which, around which axis? Y or x? When the minus is outside, reflecting around the x-axis or x-axis, exactly. So here is the minus. It's like we have to graph the original function f of x equal logarithm of x to the base 2. And this is my original function. Then we have minus outside. This is mean we have to reflect the original one around the x-axis because the minus outside the function. If I want to write it like before, like steps before, my original function is logarithm x to the base 2. And we have minus, so I multiply both sides for minus 1, minus 1, minus 1. Now I get minus o to the x equal minus log to the x. And the minus log to the x is the same as g of x. So now to graph this function g of x, I have to graph the original one, then I have to reflect it around the x-axis because the minus here is outside. So to reflect it around the x-axis, I have to do a mirror around the x-axis. And all the point we reflected around this axis, so the zero become the same thing, 0. And this point will be like around this, and here be something like this things. So this is my g of x. This is g of x equal minus log of x. Now for the second one, number 2. Who will do number 2? Number 2. Is h of x. So my original function is f of x equal log x to the base 2. I need to graph h of x equal log minus x to the base 2. How can I graph it? So first of all, my original function will be something like that. This is the logarithm function. This is the log of x to the base 2. Reflected on the y-axis, exactly. Because the minus is inside the function, that means we have to reflect it around the y-axis. How I know? I'm going to explain. So my original function of x is logarithm x to the base 2. We plug the minus 2 inside. So I get o to the minus x equal log to the minus x to the power 2 exponent to the base 2, and this is actually equal h of x. So to graph this one, h of x, I have to graph the original one, then we have to reflect it around the y-axis because the minus is inside. So here's the y-axis. This is my mirror. Now this point is 1, become like minus 1, and all the points be like this. Like this. It's not nice. Like this. And in this side, be like around something like this. So this is h of x equal log to the minus x to the base 2. Any question? Anyone has a question? Okay, so number 3. Is graph the d of x equal 2 plus logarithm. So again, my function f of x equal log x to the base 2. I need to graph d of x equal d of x equal 2 plus log of x to the base 2. What does that mean? We're adding 2 to the logarithm. What does that mean? Adding 2 to the logarithm. What does the mean of adding 2 to the logarithm?
It goes up the y-axis too.
Exactly. This is what I mean. So adding 2 means we have to shift it up 2 unit. So my original function is like this. This is the logarithm function. This is f of x. Now we have to shift this one 2 units up. Like this point become up 2 units. 1, 2. And all this up 2 units. So the graph will be something like this. And here everything up 2 units, like this. So we shift, this is the function d of x equal plus 2 logarithm of x. Here f of x equal log the x to the base 2. Here's 2. This means here we have to shift everything up 2 units like this. Up, 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 up. Here again up, up. Everything up 2 units. Any question? Again, if I need to do the steps, O of x is logarithm to the base 2 of x. We add 2 for both sides. So I get O of x plus 2 equal log equal 2 plus log x to the base 2. And this is actually equal d of x. To graph d of x, you have to graph the original function and you shift it 2 units up. Okay? Any question? Okay, so now the last things in this section, we have to know the common logarithm and the natural logarithm. What does the mean of common logarithm? So here, the logarithm, so the common logarithm. So is a logarithm, what is the definition? Is a logarithm to the base 10. And we denote it by like this. Log x to the base 10 is the same like log x without the base. Okay. Something like this. I give you example. like when I said log 10, this is mean log 10 to the base 10. What is the answer? What is log to the base 10? What is the logarithm 10 to the base 10? By using these properties,
1.
is 1, exactly 1. Look, log a to the base a is 1. So the answer is 1. And what is this number 1? Number 2, log 100. Again, log 100 is equal log 100 to the base 10. What is the answer? What is the power if I raise to the 10, they give me 100? 2. Why? Because like I said, 10 to the 2, they give me 100. So this 2 is this. This what about the common logarithm? Common logarithm is to the base 10, and we have to ignore the 10, and we can write it like this, log x. Now, the natural logarithm, the last logarithm in this section, is natural logarithm. Again, it has definition, is a logarithm to the base e. Any logarithm to the base e is called natural logarithm, and we denote it by log x to the base e is written as ln x. By the way, e, it's a number 2.7. This is e. It's called natural number. Natural number. So any logarithm to this base e is ln of x. Okay. This ln of e has some properties. So let me give you the properties fast, and we finish this section. So the properties of natural log. First one, the ln for the 1 is equal 0, always. Number 2, ln for this number e is equal 1. Number 3, ln of e to the power x is equal x. And number 4, e to ln x equal x. I'm going to explain why here, because log e, this is equal log e to the power 1. And like before I said, log 1 to the any base is equal 0. Here it is log e to the base e, because ln is to the base e. and any log e to the base e or a to the a is equal 1. That's why len of e equal 1. Here, this is equal log e to the power x to the base e, and like before, like the logarithm properties, this is equal x. And here the same things, e to log x to the power e to the base e is equal x, like using the same property for logarithm. Any question? Any question for the natural logarithm? Okay, so there is example here. What is len e to the power 8? Number 2, what is len of 1 to the power to the e for power 2? What is len e to the power 8?
8.
Is 8. Why? Because by using property number 3, len e to the x is equal x. For number 2, what is len to the 1 over e to the square? What is the answer for the second one?
Is that x?
But we don't have x here.
Oh, my bad, sorry.
Yeah, it's fine. But here I'm going to explain more. This is len of e to the power minus 2, right? Because e to the 2 here, I can raise it up to the numerator, and this is equal len to the e to the minus 2. Now, by using the properties number 3, len to the e to the x, what does they give me? My x is minus 2. So the answer is minus 2. Is it clear? Okay, so we'll finish the section by these things. If you have a question, you can ask your question before the class is finished. Do you have questions? Any question? Okay, if there is no question, I'm going to see you next week.
Professor,
Thank
is
you.
it
Yes.
the natural log same with the common log, the concept?
Which one?
The concept of natural log same with the common log.
The common log here?
Yes.
Yeah. What's your question in the common log? Again.
Is it the concept of common log and the natural log is the same?
Yes, it's the same, but here in the common logarithm, the base is 10. So log 10. See the 10? This is the difference. For the common log, the base is 10. And we can write it as log x without the base, without writing anything. But for the natural log, the same definition, but the base here is e. We can write like log x to the base e. And this things is written as, defined as len x. So len x is the same as log of x to the base e. Here, the base is 10. We don't have to write it down. So when I see something like that, log x means log x to the base 10. This is your question?
Yes, thank you.
Okay. No problem. Any other questions? Okay. See you next week. Thank you. Have a good night.
Good